30 redirects here. For the locomotive, CFS class E330. For vitamin C, C ascorbic acid. Citric acid is a weak organic acid that has the chemical formula C6H8O7. It occurs naturally in citrus fruits. In biochemistry, it is an intermediate in the citric acid cycle, which occurs in the metabolism of all aerobic organisms. Citric acid. Bird IUPAC name 2-hydroxypropane 1,2,3-tricarboxylic acid identifiers Cas number 3D model, J small, interactive image Chibi Chem Spider Drug Bank.
Hecha Infocard 100.973.
EC number 2010691.
E9BE 330, antioxydant.
IUPACR-BPS 2478 kg.
Pub Shine CID 311, 222,30.
Monohydrate, RTECS number G7,350,000.
Uni.
Inchi equals 1/C6H8O7/C7-3, 8, 1-6, 13, 5, 11, 12, 2-4, 9, 10/H13H, 1-2H2, H, 7, 8, H, 9, 10, H, 11, 12, Ki, Kirknibchiksingoxafe OIM smiles.
OC igual a O, CC, O, C igual a O, O, CC igual a O.
Properties chemical formula C6H8O7 molar mass 192.123 g mol, anhydrous, 210.038 g mol, monohydrate, 1. Appearance crystalline white solid odorless density 1.665 gcm3, anhydrous, 1.542 gcm3, 18 degrees Celsius, monohydrate. Melting point 156 degrees Celsius, 313 degrees Fahrenheit. 429 K, boiling point 310 degrees Celsius, 590 degrees Fahrenheit. 583 K, decomposes from 175 degrees Celsius to solubility in water 117.43 g/100 ml, 10 degrees Celsius, 147.76 g/100 ml, 20 degrees Celsius, 180.89 g/100 ml, 30 degrees Celsius, 220.19 g/100 ml, 40 degrees Celsius, 382.48 g/100 ml, 80 degrees Celsius, 547.79 g/100 ml, 100 degrees Celsius, 3. Solubility soluble in acetone, alcohol, ether, ethyl acetate, DMSO insoluble in C6H6, CHCl3, CS2, toluene 2, solubility in ethanol 62 g/100 g, 25 degrees Celsius, 2. Solubility in amyl acetate 4.41 g/100 g, 25 degrees Celsius, 2. Solubility in diethyl ether 1.05 g/100 g, 25 degrees Celsius, 2. Solubility in 1,4-dioxane 35.9 g/100 g, 25 degrees Celsius, 2. Log P-1.64.
Acidity, pK, pK1 rovná sa 313, 4.
pKa2 equals 4.76, 4. pKa3 equals 6.39, 5, 6.40, 6. Refractive index, ND, 1.493 to 1.509, 20 degrees Celsius, 3, 1.46, 150 degrees Celsius, 2. Viscosity 6.5 cp, 50% Axol, 3. Structure crystal structure monoclinic thermochemistry heat capacity, C. 226.51 J, mol, K. 26.85 degrees Celsius, 7. STD molar entropy, SO 298, 252.1 J, mol, K. 7. STD enthalpy of formation, FO 298, minus 1548.8.
Courriol mol, 3.
STD enthalpy of combustion, Cho 298, minus 1960.6.
KJ-mol, 7, minus 1972,34.
KJ mol, monohydrate, 3, Pharmacology ATC code A09OB04, WHO, hazards main hazards skin and irritant safety data sheet HMDB GHS pictograms, 4, GHS signal word warning GHS hazard statements H319, 4, GHS precautionary statements P305 plus 351 plus 338, 4. NFPA 700-4120 flashpoint 155 degrees Celsius, 311 degrees Fahrenheit. 428 K, auto ignition temperature 345 degrees Celsius, 653 degrees Fahrenheit. 618 K, explosive limits 8%, 4. Lethal dose or concentration, LD, LC, LD50, median dose, 3000 mg/kg. Rats, oral, except where otherwise noted. Data are given for materials in their standard state, at 25 degrees Celsius, 77 degrees Fahrenheit, 100 kPa. Verify. What is? Infobox references more than 1 million tons of citric acid are manufactured every year. It is used widely as an acidifier, as a flavoring and chelating agent. 8. A citrate is a derivative of citric acid, that is, the salts, esters, and the polyatomic anion found in solution. An example of the former, a salt is trisodium citrate, an ester is triethyl citrate. When part of a salt, the formula of the citrate ion is written as C6H5037 or C3H.
5O, COO, 33.
Contents: natural occurrence and industrial production, chemical characteristics, biochemistry, citric acid cycle, other biological roles, applications, food and drink cleaning and chelating agent, cosmetics, pharmaceuticals, dietary supplements, and foods. Other uses: synthesize solid materials from small molecules. Safety compendial status. See also references natural occurrence and industrial production. Citric acid exists in greater than trace amounts in a variety of fruits and vegetables, most notably citrus fruits. Lemons and limes have particularly high concentrations of the acid. It can constitute as much as 8% of the dry weight of these fruits, about 47 gl in the juices. 9. The concentrations of citric acid in citrus fruits range from 0.005 mol/L for oranges and grapefruits to 0.30 mol/L in lemons and limes. Within species, these values vary depending on the cultivar and the circumstances in which the fruit was grown. Industrial-scale citric acid production first began in 1890 based on the Italian citrus fruit industry, where the juice was treated with hydrated lime, calcium hydroxide, to precipitate calcium citrate, which was isolated and converted back to the acid using diluted sulfuric acid. 10. In 1893, C. Wemmer discovered penicillium mold could produce citric acid from sugar. However, microbial production of citric acid did not become industrially important until World War I disrupted Italian citrus exports. In 1917, American food chemist James Curry discovered certain strains of the mold Aspergillus niger could be efficient citric acid producers, and the pharmaceutical company Pfizer began industrial level production using this technique 2 years later, followed by Citric Belgium in 1929. In this production technique, which is still the major industrial route to citric acid used today, cultures of A. niger are fed on a sucrose or glucose-containing medium to produce citric acid. The source of sugar is corn steep liquor, molasses, hydrolyzed cornstarch or other inexpensive sugary solutions. 11. After the mold is filtered out of the resulting solution, citric acid is isolated by precipitating it with calcium hydroxide to yield calcium citrate salt, from which citric acid is regenerated by treatment with sulfuric acid, as in the direct extraction from citrus fruit juice. In 1977, a patent was granted to Lever Brothers for the chemical synthesis of citric acid starting either from aconitic or isocitrate calcium salts under high-pressure conditions. This produced citric acid in near quantitative conversion under what appeared to be a reverse non-enzymatic Krebs cycle reaction. 12. In 2007, worldwide annual production stood at approximately 1,600,000 tons. 13. More than 50% of this volume was produced in China. More than 50% was used as an acidity regulator in beverages, some 20% in other food applications, 20% for detergent applications, and 10% for related applications other than food, such as cosmetics, pharmaceutics, and in the chemical industry. Chemical characteristics. Citric acid was first isolated in 1784 by the chemist Carl Wilhelm Scheele, who crystallized it from lemon juice, 14, 10, 15. It can exist either in an anhydrous, water-free form or as a monohydrate. The anhydrous form crystallizes from hot water, while the monohydrate forms when citric acid is crystallized from cold water. The monohydrate can be converted to the anhydrous form at about 78 degrees Celsius. Citric acid also dissolves in absolute, anhydrous, ethanol, 76 parts of citric acid per 100 parts of ethanol. At 15 degrees Celsius it decomposes with loss of carbon dioxide above about 175 degrees Celsius. Citric acid is normally considered to be a tribasic acid, with pKa values extrapolated to zero ionic strength of 5.21, 4.28 and 2.92 at 25 degrees Celsius. 16. The pKa of the hydroxyl group has been found, by means of 13cNMR spectroscopy, to be 14.4. 17. The speciation diagram shows that solutions of citric acid are buffer solutions between about pH 2 and pH 8. In biological systems around pH 7, the two species present are the citrate ion and monohydrogen citrate ion. The SSC20X hybridization buffer is an example in common use. 18. Tables compiled for biochemical studies 19 are available. On the other hand, the pH of a 1 mm solution of citric acid will be about 3.2. The pH of fruit juices from citrus fruits like oranges and lemons depends on the citric acid concentration, being lower for higher acid concentration and conversely. Acid salts of citric acid can be prepared by careful adjustment of the pH before crystallizing the compound. See, for example, sodium citrate. The citrate ion forms complexes with metallic cations. The stability constants for the formation of these complexes are quite large because of the chelate effect. Consequently, it forms complexes even with alkali metal cations. However, when a chelate complex is formed using all three carboxylate groups, the chelate rings have 7 and 8 members, which are generally less stable thermodynamically than smaller chelate rings. In consequence, the hydroxyl group can be deprotonated, forming part of a more stable 5-membered ring, as in ammonium ferric citrate, NH4, 5F6H4O7, 2H2O, 20. Citric acid can be esterified at one or more of the carboxylic acid functional groups on the molecule, using a variety of alcohols, to form any of a variety of mono, di, tri, and mixed esters. Citation needed. Biochemistry. Citric acid cycle. Main article. Citric acid cycle. Citrate is an intermediate in the TCA cycle, tricarboxylic acid cycle, Krebs cycle, Krebs cycle, a central metabolic pathway for animals, plants, and bacteria. Citrate synthase catalyzes the condensation of oxaloacetate with acetyl-CoA to form citrate. Citrate then acts as the substrate for aconitase and is converted into aconitic acid. The cycle ends with regeneration of oxaloacetate. This series of chemical reactions is the source of 2/3 of the food-derived energy in higher organisms. Hans Adolf Krebs received the 1953 Nobel Prize in Physiology or Medicine for the discovery. Some bacteria, notably E. coli, can produce and consume citrate internally as part of their TCA cycle, but are unable to use it as food because they lack the enzymes required to import it into the cell. After tens of thousands of evolution in a minimal glucose medium that also contains citrate during Richard Lenski's long-term evolution experiment, a variant E. coli evolved with the ability to grow aerobically on citrate. Zachary Blunt, a student of Lenski's, and colleagues studied these CIT plus E. coli 21-22 as a model for how novel traits evolve. They found evidence that in this case the innovation was immediately caused by a rare duplication mutation that was effective in causing the trait due to the accumulation of several prior potentiating mutations, the identity and effects of which are still under study. The evolution of the Cit+ trait has been considered a notable example of the role of historical contingency in evolution. Other biological roles. Citrate can be transported out of the mitochondria and into the cytoplasm, then broken down into acetyl-CoA for fatty acid synthesis and into oxaloacetate. Citrate is a positive modulator of this conversion, and allosterically regulates the enzyme acetyl-CoA carboxylase, which is the regulating enzyme in the conversion of acetyl-CoA into malonyl-CoA, the commitment step in fatty acid synthesis. In short, citrate is transported to the cytoplasm, converted to acetyl-CoA, which is converted into malonyl-CoA by the acetyl-CoA carboxylase, which is allosterically modulated by citrate. High concentrations of cytosolic citrate can inhibit phosphofructokinase, the catalyst of one of the rate-limiting steps of glycolysis. This effect is advantageous. High concentrations of citrate indicate that there is a large supply of biosynthetic precursor molecules, so there is no need for phosphofructokinase to continue to send molecules of its substrate, fructose 6-phosphate, into glycolysis. Citrate acts by augmenting the inhibitory effect of high concentrations of ADP, another sign that there is no need to carry out glycolysis. 23. Citrate is a vital component of bone, helping to regulate the size of apatite crystals. 24. Applications. Food and drink. Because it is one of the stronger edible acids, the dominant use of citric acid is as a flavoring and preservative in food and beverages, especially soft drinks and candies. 10. Within the European Union it is denoted by E number E330. Citrate salts of various metals are used to deliver those minerals in a biologically available form in many dietary supplements. Citric acid has 247 kcal per 100 grams. 25. The buffering properties of citrates are used to control pH in household cleaners and pharmaceuticals. In the United States, the purity requirements for citric acid as a food additive are defined by the Food Chemicals Codex, which is published by the United States Pharmacopoeia, USP. Citric acid can be added to ice cream as an emulsifying agent to keep fats from separating, to caramel to prevent sucrose crystallization, or in recipes in place of fresh lemon juice. Citric acid is used with sodium bicarbonate in a wide range of effervescent formulae, both for ingestion, for example, powders and tablets, and for personal care, for example, bath salts, bath bombs, and cleaning of grease. Citric acid sold in a dry powdered form is commonly sold in markets and groceries as sour salt, due to its physical resemblance to table salt. It has use in culinary applications, as an alternative to vinegar or lemon juice, where a pure acid is needed. Citric acid can be used in food coloring to balance the pH level of a normally basic dye. Cleaning and chelating agent. Citric acid is an excellent chelating agent, binding metals by making them soluble. It is used to remove and discourage the buildup of limescale from boilers and evaporators. 10. It can be used to treat water, which makes it useful in improving the effectiveness of soaps and laundry detergents. By chelating the metals in hard water, it lets these cleaners produce foam and work better without need for water softening. Citric acid is the active ingredient in some bathroom and kitchen cleaning solutions. A solution with a 6% concentration of citric acid will remove hard water stains from glass without scrubbing. Citric acid can be used in shampoo to wash out wax and coloring from the hair. In industry, it is used to dissolve rust from steel and passivate stainless steels. 26. Illustrative of its chelating abilities, citric acid was the first successful eluent used for total ion exchange separation of the lanthanides during the Manhattan Project in the 1940s. In the 1950s, it was replaced by the far more efficient EDTA. Cosmetics, pharmaceuticals, dietary supplements, and foods. Citric acid is widely used as an acidulant in creams, gels, and liquids of all kinds. In its use in foods and dietary supplements, it may be classified as a processing aid if the purpose it was added was for a technical or functional effect, for example acidulant, chelator, viscosifier, etc., for a process. If it is still present in insignificant amounts, and the technical or functional effect is no longer present, it may be exempted from labeling. 21 CFR Section 101.100 C. Citric acid is an alpha-hydroxy acid and used as an active ingredient in chemical peels. Citric acid is commonly used as a buffer to increase the solubility of brown heroin. Single-use citric acid sachets have been used as an inducement to get heroin users to exchange their dirty needles for clean needles in an attempt to decrease the spread of HIV and hepatitis. 27. Citric acid is used as one of the active ingredients in the production of antiviral tissues. 28. Other uses. Citric acid is used as an odorless alternative to white vinegar for home dyeing with acid dyes. Sodium citrate is a component of Benedict's reagent, used for identification both qualitatively and quantitatively of reducing sugars. Citric acid can be used as an alternative to nitric acid in passivation of stainless steel. 29. Citric acid can be used as a lower odor stop bath as part of the process for developing photographic film. Photographic developers are alkaline, so a mild acid is used to neutralize and stop their action quickly, but commonly used acetic acid leaves a strong vinegar odor in the darkroom. 30. Citric acid potassium sodium citrate can be used as a blood acid regulator. Soldering flux. Citric acid is an excellent soldering flux. 31. Either dry or as a concentrated solution in water. It should be washed off after soldering, especially with fine wires, as it is mildly corrosive. It dissolves and washes off quickly in hot water. Synthesize solid materials from small molecules. In materials science, the citrate gel method is a process similar to the sol gel method, which is a method for producing solid materials from small molecules. During the synthetic process, metal salts or alkoxides are introduced into a citric acid solution. The formation of citric complexes is believed to balance the difference in individual behavior of ions in solution, which results in a better distribution of ions and prevents the separation of components at later process stages. The polycondensation of ethylene glycol and citric acid starts above, resulting in polymer citrate gel formation. Safety. Although a weak acid, exposure to pure citric acid can cause adverse effects. Inhalation may cause cough, shortness of breath, or sore throat. Overingestion may cause abdominal pain and sore throat. Exposure of concentrated solutions to skin and eyes can cause redness and pain. 32. Long-term or repeated consumption may cause erosion of tooth enamel. 32, 33, 34. Compendial status. British Pharmacopoeia 35.
Japanese Farmacopoeia 36.
See also. Wikimedia Commons has media related to citric acid. Wikisource has the text of the 1911 Encyclopedia Britannica article Citric acid. The closely related acids isocitric acid, aconitic acid, and propane 1, 2, 3 tricarboxylic acid, tricarbolylic acid,